So 0, 1 and again, I have 6 host bits to go along with it. And again, fill the host bits with 0s and 1s to figure out what the network and broadcast addresses are. So 010000000 is the network address. 0111111 is the broadcast address. I convert those from their binary format here into decimal. That gives me 64 and 127. So that's my network and broadcast addresses for this subnetwork. Everything in between is the usable range. That takes care of subnetwork number 2. And I can continue doing that for the other 2. So 10 and 11. There we go. And again, I just convert 8 bits into decimal. That gives me my network address, my broadcast address, and my usable range. Here, 10000000 is 128. This one down here is 192, or pardon me, 191. That leaves me 129 to 190 usable addresses. Likewise down here, our last one, 11000000 is 192 in decimal. All 8 bits set to 1 is 255. And so then 193 to 254 is my range of usable addresses. So there, my 4 divisions of subnetworks. Each one has 62 usable addresses in it, and these are the 4. The 00 subnet, the 01 subnet, the 10 subnet, and the 11 subnet. I assign the addresses for 3 of those for these, and I'm done. Now, a couple of details that we need to discuss. We've already mentioned the subnet mask. We have to look at what that is because we've now changed the subnet mask. As soon as we do this, we alter the subnet mask. The other issue we have to consider as well, excuse me, the 00. This is referred to as the 0 subnet, the first one that comes up, where the subnetwork bits are all zeros, termed as the 0 subnet. As a general rule of thumb, you'll normally see that it says not to use the 0 subnet. That's kind of a general rule of thumb. It's not an absolute rule, though. In fact, some devices, for example, Cisco devices, can be configured to either allow the use of the 0 subnet or not allow the use of the 0 subnet. So as a rule of thumb, you will occasionally see that something saying that you're not to use the 0 subnet. In our case, we'll just go ahead and use it. It's not a big deal. So the other thing that we have to look at to finish this all off is our subnet mask. The way that we figure that out is we take our original subnet mask, our original default subnet mask, and alter it to account for what we did here in shifting this over and borrowing these 2 bits. So what we've effectively done here, our original default mask would have been, say, in this case, /24, or 255.255.255.0. That was our default subnet mask. What we have now, if I write that out in binary, we can see what we've done. So there's our original subnetwork mask. As soon as we did this, what we did was we moved this over to here. Like that. That's the effect of doing this. The original default mask meant that the division between network bits and host bits was here. We've altered that to move it over to here. So now we have to alter our subnet mask to reflect that. And we do that by changing these 2 bits to correspond to the 2 that we borrowed to 1s. Now we take that, we convert this back into decimal. That gives us our final subnetwork mask for all of our addressing, for all of our subnetting. Convert that, what we get (255.255.255.192). That would have to go along with every address when we assign to hosts. Say for example, if I assign a host in this subnetwork 192.168.150, along with that I would have to specify 255.255.255.192 as the corresponding subnet mask when I configure that host. If I don't do that, I will not have configured this properly, and my networking isn't going to work properly. So it's important when we figure this out that we don't just figure this out, we also have to calculate the appropriate subnet mask to go along with it. And all we do is take the default, look at how many bits over we moved that dividing line, how many bits did we borrow, account for that when we write it out, do the conversion back from binary to decimal to get our subnetwork mask, our new subnetwork mask to go along with our subnetted network.